All right, what up, you guys? Welcome back. We're doing some more chapter 12 stuff. This time dealing with quantum numbers, so NL, ML, MS. I really like this section, and usually when I do groups like this in person, people are asking tons of questions in this group. So if you go through this video and you're having questions, write down the questions as they come up, and then feel free to send them to me over email or do your own research in the book. But yeah, totally normal to have lots of questions during this. Anyways, let's get to it. So N, this quantum number is the principal quantum number. Principal quantum number. It can also sometimes be called the shell. Right, so remember earlier in chapter 12 when we were talking about ejecting electrons, we did n is equal to 1, jumping up to n is equal to 2. We were talking about n, so it's like the shell. It tells us about the size and the energy of the orbital. And hopefully that makes sense with what we already know about n levels. So I drew n is equal to 1 here. Remember, it's lower energy because it's closer to the nucleus, so that tells us about its energy, and it's smaller, right, because it's closer. So just some stuff you guys already know from doing electron transitions. And we have lots of possible values for n. The lowest one, is it 1 or is it 0? The lowest one is 1, it could be 2, it could be 3, all the way up until technically infinity. The main point here is it can't be like 0.5, it can't be like 2/3, they're all whole numbers. Cool. Next, we can talk about L, where L is the angular momentum. Or you might hear it be called subshell. Right, subshell because it's the level below n. And the L value tells us the shape of the orbital. So is it shaped like a peanut? Is it shaped like a sphere? And the possible values of L, what do they depend on? The possible values depend on the level above it. So the lowest value of L could be 0, it could be 1, it could be 2, it could be 3, all the way up until whatever n is minus 1. This means that for any n value, the L values that go with it just have to be smaller than the n value. So if n is so let's say like if n is equal to 1, that means L would have to be n minus 1 or 0. And we'll see more examples of this in the next section, the next question. That doesn't make sense. Also some common L values to know. So we have L, let's say like L is equal to 0, it's equal to 1, it's equal to 2, it's equal to 3. These are when we get really familiar orbitals. So a 0 would be an s orbital, a 1 would be a p orbital, a 2 would be a d orbital, and a 3 would be an f orbital. Good way to remember this is SPDF, some people dance funny. So if you can remember some people dance funny, just write that, put the lowest value 0 with S, and go down. And this will help us, this little some people dance funny will help us in the next questions on this handout too. Cool. All right, next doing ML. ML is known as the magnetic number. And the names aren't super important, but the meaning is. So ML will tell us the orientation of the orbital. So it'll tell us like where it is. If there's, you guys are familiar with this being the y-axis, this is the x-axis. There's also some axis, z-axis, pointing out towards you, pointing towards you out of the screen into your face, and then this back arrow is pointing behind you to the back of your computer screen. So it might be listed as like it's on the xy axis, it's on the xz axis, it's on the xyz, depending on the orbital. So anytime, the main point is anytime you see like xy, xz, xyz, it's telling you about the orientation of the orbital, which is ML. So what possible values can you have for ML? Well, it depends on whatever L is. ML values can be negative, so it's whatever L is, the negative version of it, all the way to 0, and then all the way up to whatever positive L is. Cool. And we're gonna take a little side trip here, just to talk about a little side example. So let's think about, let's say we have L is equal to 1. Okay, that means that it's a p orbital. And what are p orbitals shaped like? P orbitals are shaped like little peanuts, right? Little infinity signs. Cool. So what are the possible ML values? So L is equal to 1. That lets us know we have a peanut. The ML values we can have will be up to negative L, or down to negative L, so -1, all the way up to 0, and all the way up to positive 1L. This lets us know we have 3 ML values, or 3 orientations. Can't finish that, but you know what I mean, 3 orientations. And let's think about what that means. So bringing back this y-axis, the x-axis, the z-axis, pointing towards you on this end and pointing in your screen the other way. Let's think about the 3 different ways we could put a peanut on here. So we could put a peanut on the x-axis, we could put a peanut on the y-axis, and we could also put a peanut on the z-axis, right? There's no more axes for us to put the peanut on. So these are the 3 possible orientations of a peanut. And that is really cool because there's, according to the ML values, there's only 3 orientations, right? So we see this in 2 ways. The ML value tells us there's 3 orientations, and also just by trying to draw a peanut on the axis, we realize there's only 3 ways to do it. So that's really cool. Hopefully you think that is cool. Next, dealing with the last one, I guess we'll do green, is MS, or this is the spin number. It tells us about the spin of the electrons. It tells us about the electron spin. By the way, how many electrons are there per orbital? There'll be 2 electrons per orbital. And electrons can either spin up or they can spin down. So MS can be either +1/2 for the electron spinning up or -1/2 for the electron spinning down. And unlike the other ones, they don't really depend on anything above them. Just know that if this is an orbital, if one of them is spinning up, the other one's spinning down. You could also draw with one spinning down and then one spinning up. It doesn't really make a difference. Okay, cool. So we're going to use all this information in the next couple of videos. So if there are any questions here, let me know, or the next couple of videos might clear up how we're going to use this information.